In the next presentations, I want to present you in more depth the VISUS multi-hazard characterization. We have already seen in the previous modules that the VISUS methodology tries to replicate the expert assessment process, dividing it in three main steps. The characterization, when the expert looks at the reality and acquires the substantial information that allows him to understand what is the situation. The evaluation, so when the expert uses his knowledge in order to elaborate this information and express the judgment, that is the third step of the methodology. So the expert expresses his or her judgment on the situation he is assessing. VISUS adopts these three steps, but the first step is applied by a surveyor. The second and the third step are pre-codified and elaborated in an automated way in order to have a similar judgment as an expert would have. I just want you to show these slides once again, just to remember you the division adopted by VISUS of the survey and of the evaluation process. So the survey process consists in the collection of the substantial information. This collection of substantial information is strictly connected to the evaluation process, as the substantial information to collect was defined by the experts that expressed that used their knowledge in order to say which information is substantial and which information could be discarded during the survey. The problem here is also how to organize the survey for the collection of the substantial information and how to acquire the information. The survey information allows then the evaluation, that is applied in an automated way using the rules and criteria defined by experts. In this presentation, I want to show you the VISUS survey forms and the tools for survey that have been developed for the VISUS methodology. In fact, the characterization phase of the VISUS methodology is done by VISUS surveyors that are non-experts, that are usually students of the last year of engineering or architectural faculties or technicians that are trained in order to correctly and efficiently acquire the substantial information that are the base of the VISUS methodology and that will be elaborated in an automated way by the rules and the criteria written in the VISUS software, in the VISUS algorithms. In this slide, I want to show you the set of VISUS OBS that are the substantial information identified by the experts. As you can see, they can be summarized in 4 pages containing all the observables necessary for the visual inspections of the schools. These observables are represented through a graphical language that has proven to be the most effective way to show the information to the surveyors and that allow them to simply recognize the VISUS OBS in the reality they are looking. So as you can see from these small images, the VISUS OBS are represented by pictograms and are also described through a text in the page. The VISUS survey forms are a tool that support the identification and the collection of the substantial information for the school complex. So they concern the location, the schoolyard, the building, and the accessories. They can be filled by using a printed version, a paper-based version, or through a tablet application. The VISUS forms are divided in 5 main sections. The first section concerns the general information. It's called SP0, where SP stands for a survey phase. So survey phase 0, in this phase the surveyors should acquire the general information. So they should ask for information about the school and the potential hazard that concern the school. This information can be acquired during the preparation in a pre-survey desk work. Then there is the second survey phase that consists concerning the location inspection, and where the surveyor should look at the location where the school is placed. Then the survey phase 2 is the schoolyard inspection, where the surveyor should walk around the schoolyard and acquire information concerning the schoolyard. Then, for each building, there should be a building external inspection and a building internal inspection. All these inspections are done during the survey, the on-field survey of the school. At the end of the survey, there is the data check and the post-survey desk work, when the surveyors can check the information and the picture they acquired during the survey. We have seen that the VISUS ops are the substantial information that is essential to acquire for the characterization of the safety situation of the schools. The VISUS ops are represented in the VISUS methodology through different symbols. In particular, there are the following differentiations. First of all, the substantial information concerning the hazard that could affect the school, the reference events that could affect the schools, are represented in a symbol that is in a diamond symbol with a solid line. Here, as you can see. This is called reference event substantial information, and the surveyor can acquire this information from other maps or local knowledge, and usually this information is acquired with the support of a coordinator of an expert. Then there are the OBS, the VISUS OBS, the observables, that are the substantial information that a surveyor can observe in a school. We will see that the OBS are represented by a pictogram and by a description, a brief textual description of the scenario or of the feature that has to be identified. And we will see then that each OBS has a code that provides information on each OBS. There is also there are three typologies of OBS. The first are the typological OBS, that are OBS that describe a characteristics. The typological OBS are represented through a circle represented with a solid line. This is an example of typological OBS. A typological OBS can be identified by surveyors by the simple observation of the reality and the direct association or identification with a pictogram. So the surveyor looks at the pictogram, looks at the reality, and can check and compare them. Then there are the behavioral OBS. A behavioral OBS describes the potential critical consequences if the referent event occurs. Here you can see an example of behavioral OBS, and small here you can see in the bottom left corner of the OBS a very small image that represents the reference event. In this case is a very small symbol of an earthquake. So The behavioral hubs is represented by a circle with two lines, a solid line inside and a dashed line outside. The behavioral hubs are based on the recognition of an expected response to specific action. So the surveyor has first to recognize the different features that could characterize a specific response, and then evaluate if the response is credible for the reference event. In this case, in the image, you can see some plants in the vases put above a rail. In case of an earthquake, these vases could fall on persons behind this rail, so they could cause problems to the persons. Finally, there are the status hubs that are represented by a circle with two lines, blue lines. The status hubs represent the essential information for evaluating the status, the quality of conditions of the school. The hubs are described, as I told you before, by a code. Each hubs has a specific code, where each symbol in the code has a specific meaning. The first number of the code, in this case a 1, represented the survey phase when the hubs can be recognized or acquired. So, in the case, if the number 1 is reported, this hubs concerns the survey phase 1, that is the location inspection. Number 2, the schoolyard inspection. Number 3, the building external inspection. And number 4, the building internal inspection. Then there is a letter. In this case, the letter G, but the potential letters here are the G, that this letter represents the aspect analyzed by the code. So the letter G concerns the all hazards, the general aspects of all hazards. The letter U, the ordinary use, F for fire, W for water, E for earthquake, and A for air hazard. Finally, S concerns the status. Then there is a focus group represented by a number, and we will see this later on, and a progressive letter of the code of the hubs within the focus group, so A, B, C, D, and so on. Finally, after a dot, there is a last letter that refers to the safety issues represented by that code. In this case, the letter is the L and indicates, as you can see by this legend, it refers that this code refers to the location of the hubs. But the hubs could refer to a general description, so with a D, to the structure with S, to a portion, to local or envelope with the P, to non-structural elements with N, or to the functionality aspects with the F. So the hubs are somehow connected with the VISUS safety rules we saw and with the VISUS safety issues we saw in the previous presentations. Let's now see in depth the VISUS survey forms. I want to show you the paper-based version because it's simpler just to illustrate, but there is also a web application containing all this information. As I told you before, the paper-based version, the VISUS survey forms, is divided considering the 5 essential survey phases. Survey phase 0 concerns the general information, then survey phase 1, the location inspection, survey phase 2, the schoolyard inspection, survey phase 3, the building external inspection, and survey phase 4, the building internal inspections. These two survey forms, these two survey phases, should be filled for each building of the school complex analyzed. Finally, there are two forms that allow to depict a school sketch, indicating some important elements, and to take notes on the school surveyed. Here I want just to illustrate you some terminology used by the VISUS methodology and some abbreviations adopted therein. So, as I told you before, there are different aspects analyzed by the methodology. So you can find general aspects, and there are observables required for the evaluation of all hazards. And there are ordinary use aspects that are OBS required for the evaluation of ordinary use, fire, water, earthquake, and air hazard that are OBS required for the evaluation of the specific hazard, and finally status that are OBS required for the evaluation of the status of the school. As I told you before, the VISUS survey forms are available also in their digital version and can be used to collect both data and picture. So the digital version is to prefer because it allows to simpler acquire the data and also allows to have a quick check of the completeness of the acquired information. The VISUS application simplifies also the procedure for the data collection, but on the other hand, obviously it requires a device for its use. Now I want just you to provide an overview of the VISUS survey forms, starting from the SP0, the general information form. So as you can see, in the general information form, there is a space for assigning, for identifying the school ID code of the school that is assessed through that form. And if necessary, the surveyor can assign a temporary code for his or her purposes. The survey date and also to indicate the representative picture of the schools and pictures of the overview concerning the overview of the school, just to have an overview of the school assessed. Then there are school information contacts, so the information of the school name, the state where the school is, the coordinates of the school in order to represent it in the maps. The contacts of the persons in the school that in order to before going in the school in order to have a reference person there, and the information about the survey team that performs the survey of the school. Then there is, here you can see different approaches, different versions in the paper version and in the digital version. For example, in this case, you have the usage, the type of the school, if it is public, private, religious, the daily usage, if it is day only or day and night, the weekly usage, which days the school is used, and the yearly usage, in which month the school is used, and the grade levels taught. Then the number of people in the school during, obviously, in the period of the survey. For example, in the digital version, the sums of the total number of persons there are automatically calculated. Then there is a section for the characterization of the hazardous events, and there is a specific section for the events experienced by the school. So you can gather, the surveyors can gather information on the hazardous events experienced by the school, and usually this information is acquired by asking to school personnel or through a research on historical events. This information is acquired for each hazard, so earthquake, tsunami, volcano, landslide, flood, mud flow, debris flow, wind, sandstorm, lightning, fire, wildfire, or other hazards. So in this case, the hazard information is very specific. Then there is the identification of the reference events. the referent event defines and describes the hazard values adopted in VISUS as a reference for evaluating the likelihood of the impact scenarios. So, the reference events are defined by the VISUS local committee. It could be defined accordingly to national standards of codes, defined so at national and country level, or if this information is not available, it is possible to exploit local knowledge considering, for example, past events, so just considering events that already affected the area in past periods. The information acquired in the VISUS methodology for the reference events is described through precodified values. The reference events characterization is assigned to each hazard through a specific section. We will see in detail this section for each hazard in the next presentations. In the following, we are looking at the air-related hazards that in the VISUS methodology are represented through these symbols. Now I want to show you a video illustrating what could happen in case of strong air hazards. This video was acquired in YouTube and it is used as a potential identification of what could happen, that is the potential expected impact, the impact scenarios that could affect the school. So here you can see a street, light street with electrical lines during a strong wind day, and some trees, and here a tree that falls on the electrical line with consequences on the ground. As you can see, if someone was outside here, there are external threats. First of all, the potential for walls and so on. Then the collapse of electrical lines that causes potential very dangerous causes to persons. And in case of strong wind, there is also the flying of falling objects that could cause severe consequences on persons if they impact persons outside. In the video, I showed you only some cases of potential consequences of strong air hazard. In the VISUS methodology, we considered all the substantial impact scenarios that could occur in case of strong air hazard. And we assigned to each of these impact scenarios if it can be associated to the schoolyard, this symbol, or to the building, this symbol here, or to both. In this case, in the air hazard, we identify the following potential scenarios. The potential presence of large items of debris in the schoolyard, but also inside the building if the building allows the wind inside. The potential structural collapse of the building, or only the damage of the building after strong wind. If the building is light, it could, because of the wind, slip, or it could be uplift. Or there could be the disconnection of the different parts of the building, so of the walls, of the roof, and so on. There could be local collapses of some portion of the buildings, or, for example, there could be a very often the roof can be detached from the structure and fly away. There could be local detachments of the envelope of the building, or the roof, if it is not completely detached, it could be uplift. And there could be roof scrape of the roof with severe consequences, or with only difficulties, and there are specific different scenarios that represent these two cases. Then there could be scenarios concerning the presence of flying or falling objects inside the buildings, causing or severe consequences or difficulties, for example, if the objects are light. Or there could be flying or falling objects outside the buildings, so in the schoolyard, causing severe consequences or difficulties also in this case. There could be the collapse of the electrical lines, causing severe consequences, as you have seen in the video, or external threats like the fall of poles, trees, and so on, causing severe consequences. Concerning the building, there could be some situations for which during strong wind events the water could fall inside the building, or there could be wind inside the building causing severe consequences or causing only difficulties. Finally, there could be the impossibility to reach a safe zone during a windy event, or there could be only difficulties in the path to a safe zone. In these slides, I summarize all the elements that are required in order to characterize the air hazard and the impact scenarios I previously explained, that were the main scenarios identified by the experts. So there is the need to characterize the hazard action of the wind and to characterize the wind force, the wind speed, eventual wind speed modifiers. For example, the land roughness could attenuate the wind, the hazard action, or could increase the hazard action, and the presence of potential debris generation in the site where the school is located. There could be protections against wind in the school, and then there is a necessity to characterize the schoolyard, so to characterize the potential presence of elements that could fall, of elements that could form from nearby buildings, or that elements that could fall from the school buildings. And also for the schoolyard, the necessity to identify the presence of egress path or of shelters and of early warning systems. For each school facilities, for each building in the school, there is a necessity to characterize the potential structural collapse, the potential problems in the structure, characterizing therefore the structural system, the distribution and organization of the lateral resisting elements of the building, the characteristics of the floor and the roof that contribute to the potential activation of some impact scenarios. So if the roof has some characteristics, it will be more prone to, for example, to scenario concerning the roof uplift. The building weight that is important, for example, in the scenario of in which we saw that the building could be uplifted and moved from its position. The air permeability of the building, so we should consider all the openings of the buildings. The connection of the building to the ground that is not so sure, for example, considering temporary buildings like shelters and so on. The roof slope, that is an element that could increase the wind action in the building, and also the irregularities of the building, which are also elements that could increase the wind action on the structure. Now I want to show you what is the information acquired for the location inspection in case of air hazard, and some pictures associated to the OBS. So for the location inspection, there are two main focus groups called 1A1. 1 is the survey phase 1. A stands for the hazard A, air. And the second one is the first focus group in this survey phase. So the land roughness, the focus group concerning the land roughness. The land roughness is an essential information for the characterization of the wind speed, of potential modificators of the wind action. And the second focus group concerns the debris generation in the location. Just to show you some examples, it is possible that concerning the land rawness, the building is located in the area with scattered buildings, so the building has minor protection, as in this case you can see from this picture, acquired during the VISUS AIT pilot project. Or the building can be surrounded by tall buildings, so somehow it is protected from strong winds, as you can see from this case of this school. Concerning the schoolyard inspection, there are three main focus groups that the methodology assesses: the protection from wind hazard, the presence of elements that could fall because of wind hazard, and the presence of shelter. So in this case, I show you an example of potential falls of trees or poles because of air hazard. You can see here the image, the photo of a tree that in case of strong wind could fall and impact the building. Or in this case, in the second image, you have the potential falls of suspending live lines, in this case electrical line above a school. Concerning the characterization of the external inspection of a building in case of for the air hazard, we have several focus groups to assess. First of all, there is, for the air hazard, the characterization of the potential local intensity increase. So in some cases, if buildings are in a particular predisposition, the air action could increase because and there could be, for example, wind bursts and so on. Then it is important to characterize the air permeability of the buildings, characterizing the openings. As in this example, you can have small openings that are always open, or you can have enclosed openings. So in case of wind, it is possible to enclose the openings. There will be no wind, strong wind inside the building. Then it is necessary to understand the connection of the building to the ground, the roof shape that could cause suction, and the roof slope that also concurs to suction issue. The presence of irregularities in the shape of the building that could cause local stresses, local increases of the air action, and consequently local stresses in the structure. Then there could be falls from nearby buildings or elements, or falls from the building, such as in this example, there could be objects that could fall from the building after, in this case, after the egress. So this could be a very dangerous situation in case of strong wind. Moreover, it's important also to characterize the structure of the building, its structural system, the resistance of the material, the construction quality and the building condition, and the roof covering and the architectural features. Concerning the building internal characterization, there are different focus groups to inspect. It is necessary to inspect the connection of the structural elements to see if they can withstand the wind action. So if the roof could be uplifted or not, or detached from the walls. If there could be falls of elements or objects inside the schools in case the wind could enter into the schools. For example, in this building, the false ceiling could fall if wind enters into the building. Then the egress, and if the building is conceived as a shelter for during strong wind situations. In general, concerning general hazards, all the hazards, it's also necessary to look at the floor behavior and connection, So if the floor can detach from the structure, the roof behavioral connection, the roof decking. So if the tiles or if the sheets of the roof are removed by the wind, if there is an additional protection from wind of the structure, or if, for example, the water enters and the wind enters directly in the building, and then the quality of the material of the school. Let's now consider earth-related hazards. For the earthquake hazard, I want to show you a video of people that escapes from this building during the 7.3 Iraq earthquake. So you can see the people raises and then tries to escape as fast as possible, and here you can see the glass that breaks and that could strongly affect people, especially if they were childs. This could be a very dangerous problem, a very dangerous situation during the escape. So in this case, we can see the presence of fall of objects inside the building, the difficulty egress from this building. Here you have another example from inside, and and here you have some examples of damages to structure, the fall of objects inside in the building, the overturn of objects. These are common situations during all earthquakes. For the earthquake hazard, together with experts, we identified the following substantial impact scenarios. First of all, concerning school and buildings, there could be natural threats causing severe consequences, for example, landslides, or there could be natural threats causing difficulties, for example, the presence of liquefaction. Or there could be human-induced threats, for example, if the building is close to a dam that collapses, or to other industrial facilities that collapses, there could be human-induced threats. Then the school buildings, the school facilities could collapse because of the earthquake or could sustain damage. Or there could be partial collapses of the structure or local failures, so local damage. There could be the fall of objects inside, causing severe consequences if these objects are heavy or in strategic positions. Or there could be fall of objects causing difficulties, as in the previous video I showed to you. The fall of objects caused only difficulties to persons. There could be the overturning of the objects, causing both severe or difficulties. And then there could be, in case of presence of hazardous material, there could be releases. So, for example, releases of gas. There could be outside, there could be also the fall of objects causing difficulties or severe consequences, and there could be also falls from other constructions. We separated this because we just wanted to consider the perspective of the decision makers that can intervene in a way on the buildings belonging to the school and in another way to the buildings that are outside the school. Finally, there could be the situation in which the exit is compromised, as if you remember in the example, in the very simple case we show at the beginning of the presentations, the heavy object falling not on persons but on an empty hallway could compromise the exit from the building, or there could be difficult egress. Finally, there could be the case in which there are no safe areas, and so there are difficulties for the persons in the building in case of an earthquake. The main factors that contribute to the characterization of the earthquake situation concern first the hazard characterization, so concerning the predicted seismicity using hazard maps or local knowledge, and hazard modifiers. So, for example, the soil stiffness, the geomorphology permits the characterization of these modifiers permits to understand if the seismic action will increase or not from the reference one. And then there are the local characteristics that also could modify the hazard action. So there are the natural and the human-induced hazard. There are potential fall of elements in the schoolyard. It is necessary to consider the egress and the presence of a safe area both from the schoolyard and from the buildings, and the presence of collapses from the structure, damage, and releases, falls from buildings, or, for example, if the building has anti-seismic devices that protect the building in case of an earthquake. So it is necessary to look at the structural system of the school buildings, the distribution of the lateral resistant elements, the characterization of the floor and of the roof, the building height, the construction quality, the behavior of the structure, if this good behavior or not good behavior, that means a unitary or not unitary behavior, if the building completely crumbles under the seismic action, it is a very poor behavior. If there are local characteristics causing severe damage, like soft floor or irregular distribution, weaknesses, and so on. In this case, I just want you to summarize what are the focus group for the characterization of the earthquake hazard for the location inspection. In this case, during the location inspection, it is necessary to identify the soil stiffness that could modify the hazard, the geomorphology that could also modify the hazard affecting the school, the local characteristics, then the topography, the presence of natural hazards such as landslide, potential landslides, rockfalls, and so on, and the presence of human-induced hazard. In this picture, for example, I show you this is a school under a potential rockfall of material. Here you can see. And so this is the VISUS OBS that refers to this potential problem collected in Peru. And then this is, for example, the case of landfill, a school located on a landfill, and the presence of landfill could amplify the hazard, the seismic hazard in case of an event. For the schoolyard inspection, in case of an earthquake, it is important to identify the presence of potential faults of elements, such as in this picture. You can see that this structural element that is not a school building, is not an ancillary or main building, but is an accessory in the school, it could fall and hit students or persons in the schoolyard, causing very severe consequences, and also the presence of safe areas where the child can go and find a safe space. In this image, for example, you see the potential fall of a fence wall on children. Then, concerning the buildings, there are the focus groups concern the foundations of the buildings, the presence of stress focus and local weaknesses in the structure of the buildings, the presence of potential falls from nearby, so from buildings close to the assessed buildings, or falls from the building that is assessed in that moment, and the characteristics of the egress from the building in case of seismic hazard. In general terms, it is also necessary to understand the presence of natural hazards on the building, the plan shape of the building that could affect its response during the seismic event, the elevation shape, the structural system, and the horizontal distribution and organization of the lateral resistance elements. In this case, you can see from this image the presence of a local problem, where here you have a column with no column behind it, so the local stresses just will have a discontinuous load path, and this could cause a problem in case of an earthquake. Then there are, for example, evidences of existing severe damage, like in this case, that could strongly affect the structural behavior during an earthquake. Finally, in this image you can see the potential fall of unsafe elements causing severe consequences. Here you have all these vases that could fall from above on an exit. Concerning the internal characterization, it is necessary to check for if the structural behavior of the building is not as a whole, the presence of soft floor, the presence of irregularities in the vertical mass distribution, the weaknesses, the potential increased stress or displacements, the failure hazards, fall of elements, the presence of eventual anti-seismic devices that improve the performance of the building, and the egress from the building. Also, in this case, it is necessary to understand the floor behavior, the roof behavior, and the weight of the building. In this image, I just show you some example of critical weaknesses. You see here, in order to permit the passage of this pipe, this arc was strongly affected, causing a local very strong weakness. And also in this case, there could be the overturn of these non-structural elements, but they are heavy, and if they fall, they could cause very severe consequences on child in the school.